In this video, we will try to derive the limit of duality of trig functions using this very, very important limit, right? So we have a list of trig functions, sine, cosine, tangent, secant, and cosecant, right? Let's try to develop sine and cosine because tangent of x is same as sine over cosine. You can apply quotient rule, right? So basically, if you know the duality of sine and cosine, you know the duality of all the others by applying the quotient rule or some other rules, right? Let's see that we want to differentiate d over dx sine of x, right? Now what's this, right? And let's see the evaluation, right? And so this is equal to, right? We have no formulas, right? All we can do is use our definition. So definition is this as h goes to 0, sine of x plus h minus sine of x over h, right? How do we do that, right? And recall that we can change the sign of sum of two numbers to a sum of some trig function, right? And so this is equal to as h goes to 0, you get what? Sine of x cosine of h plus cosine of x sine of h minus sine of x over h, right? Okay, now we are good, right? If you look at the middle term here, you get sine of h over h, right? The other two terms, recall that we have an example. We know that as theta goes to 0, cosine of theta minus 1 over theta, this one goes to 0, right? So this is, we can use our very, very important limit to get the second limit by easy conjugate calculation, right? And so we split our big limit. So this equal to as h goes to 0, right? Group the terms has the similar factors. So first and last, right? Sum x is common factor. You get sine of x times cosine of h minus 1 divided by our denominator, which is h, right? Then plus cosine of x times sine of h over h. Now we can plug in our limit, right? As x goes 0, as h goes 0, this doesn't change, still sine of x because that term doesn't contain h, right? This factor here goes to 0 by our limit above, right? This is we did our calculation. This cosine of x doesn't change because that doesn't, as h change, cos x doesn't change, right? And the sum of h over h, that goes to 1, right? This one goes to 0, this one goes to 1. We plug in all the corresponding numbers, so this is equal to cosine of x, right? So we get our first formula for the duality of trig functions, right? So which is sine of x prime is cosine of x, right? To get the duality of cosine, you apply the same method, and using the limit we have here, we can get cosine of x prime is negative sine of x, right? That's good. Now, what's the duality of tangent of x? That's, now we don't have to evaluate limit because by our big discussion, we just know that tangent of x prime is sine of x over cosine of x prime. We know the derivative of the numerator and denominator, and for sure we can apply our quotient rule, right? So this is cosine square of x, you get cosine of x times cosine of x minus sine of x times negative sine of x, right? So you get this is cosine square of x plus sine square of x over cosine square of x. Now the numerator is 1 because this is one of the most important trig identities, right? Sine square plus cosine square is 1. So this is 1 over cosine square of x. It has a better way to write down. This is negative secant square of x. No, plus, sorry. Secant square of x, right? Because secant is 1 over cosine, so tangent prime is basically secant square of x. And if you try to write down more, and cotangent of x prime is negative cosecant of x cosecant square of x, and secant of x prime is secant of x times tangent of x, and cosecant of x prime is negative cosecant of x times cotangent of x. Right, so this is basically a list of the derivative of a trig function, sine, cosine, tangent, and cotangent, secant, and cosecant. That's how do we differentiate them, right? That we know how to differentiate that. Either the first one and second one, we have to use our definition of limit, and all the others using quotient rules, you can get what that, right? Okay, now let's see example, right? Let's see example. Let's try to differentiate some function with sine function, cosine function involved, trig function involved. So this is e to t times sine of t over e to t plus tangent of t, right? Let's see how do we differentiate this function, right? So h prime of t is what, right? This is a quotient, right? Apply quotient rule first, right? This is a quotient, apply quotient rule, right? You get e to t plus tangent of t square. Now the derivative of the numerator, which is e to t times sine of t prime minus e to t times, no, wait, I missed a term, right? Times the denominator, which is e to t plus tangent of t, right? Then minus e to t times sine of t times e to t plus tangent of t prime, right? Then we can just apply the trig functions, and also for the first term, we need to use a product rule here, right? And let me try to write down. So this is e to t times sine of t plus e to t times cosine of t. So that's how do we differentiate that term. Then keep the other terms without changing that, because there's no derivative involved in the second factor, minus e to t sine of t. The derivative of that sum is using our, what's that, sum rule, right? Plus secant square of t over, and that's in change in our denominator, which is e to t plus tangent of t then square, right? This is how do we differentiate this big function with sine trig functions and exponential function involved. Apply quotient rule and product rule all together, and for sure you have to use sum and sum rule, right?